I'm excited. This is like the first time I've made, I guess, curriculum by myself. So it'll be interesting.
Heck yeah. I'm excited.
Anyway. Oh, yo, what's up, Stu?
Hello. Am I heard all right?
Yeah, you're good.
Flawless.
Yeah, and I'm also going to be recording this, so I'll upload the recording onto our YouTube channel after this is done as well.
Oh, good.
But yeah, I guess I'll wait like 2 minutes, see if anyone else shows up, and then we'll get started.
Sounds good.
How's everyone's evening been?
Busy. I'm still playing catch up from when I was sick, but I'm almost done all of my computer science labs for the rest of the term, basically. So.
Heck yeah.
Yeah, that's pretty good.
And then from there, it's just working on a YouTube video script. How about you guys?
Yeah, I've just had like a class, and then I've been working a bit on the RPG, finishing off some animation stuff. It's fun.
I've just been big chilling. I got
Nice.
like my last big assignment done for the next little bit, so I was just taking a day off.
That's good to hear.
Yeah, that's nice.
All right, well, I guess we'll get started. So I'll start sharing my screen here. And then I will also change the scene on OBS. Okay, welcome. Intro to Godot, the game engine. This is going to cover very basics of like two-dimensional stuff because 3D is hard. But what are we going to learn? We're going to learn how to install Godot and create a project. Those are pretty basic ones. We're going to learn about the editor layout. We're going to learn how to import assets. We're going to learn what the node system is and how that works. We're going to learn how to do some basic scripting. We're going to learn about project settings. There's a lot of handy stuff in there that you can fiddle around with. And we're going to learn about a few extra other things. If there are questions, Jaden will be watching the chat, and then he will interrupt me to ask. If that should work. And that's how we'll do questions. So, first thing, installing Godot. Go to that website, go.engine.org/download, and then download the standard version, and then run the executable. There's like no installer or anything. You just run the Godot executable. So if I go here, oh, we don't need that one. This is the page you'll see, and it'll show you for your platform. I'm on Linux, but if you're on like Mac OS or Windows, you'll pick those ones. But yeah, there's the standard version, and then the C# support version. We're not going to be using C#, so you just need the standard version. And yeah, you just download that, and you'll be good to go. There we go. All right, next. Project creation. It's really easy. You run Godot, you hit the create new project button, you name your project, and you put it in a folder, and you do it. So let's go over how to do that. I'll just pop over here, and I'll need to go to my documents and just run Godot here. And I'm going to bring this back. I made like sprites and everything. I'm so prepared. Okay. So we're not going to open the asset library. We don't need that. But the way this works, you just say create new project, and we're going to call this live, because this will be the live version. And we're going to put it in here. And then create folder. So this create folder thing is because a Godot project needs to be in an empty folder. And yeah, you just hit create folder, it'll create an empty folder for your project. OpenGL 3.0 versus 2.0, this is just your OpenGL version. You can use 3.0 for basically everything, and it's better than 2.0 anyways. So pretty much always use that, especially if you're doing 3D. But it says here as well, like 2.0 is recommended for web games. So if you're doing a web game, do 2.0 because it's a bit easier to run. So we're just going to hit create and edit, and that'll open up the Godot editor for us. So are there any questions so far? No? Okay, am I going too fast, or is this a good speed?
Nope, I'm set up. I'm all good to go.
Okay, cool. Epic. All right. So next part in the slides is editor layout. Yeah. So I have this little thing here where I've highlighted all the different parts, but we're going to actually go through what everything is. So the first thing here, this big window, this is like your main view. Up here, you can switch between a 2D view, which will show you like a 2D scene, a 3D view, the script editor, which is really handy. Godot actually has like a built-in script editor. And the asset library, which if you used Unity before, this is essentially the asset store. Except this is like fully built into Godot, and you can just like import stuff straight into your project. It's pretty sick. But we're not going to be using that for this, so we're going to ignore it. Since we're going to be working in 2D for this tutorial, we're just going to go to the 2D view, and that's what we'll be working out of. Next thing is the scene view, or scene hierarchy, whatever you want to call it. This is this one right here. So this is where you will see the hierarchy of nodes in your scene. Right now, since we don't have any nodes, it's just wanting us to create one. So we can create like a 2D scene, a 3D scene, or a user interface scene, or something else. And I'll explain how that works in a little bit. But normally you'd see like a hierarchy here. Okay, yeah, the next thing is just the file system. This is your asset browser. All the assets in your project are here. You're going to have all your sprites, animations, scripts. Everything's going to be in this panel, and it's like a folder, basically. So you can, create new folders, create scenes, scripts, all that stuff. Next thing is the inspector. That's this guy over here. This is pretty much identical to like the inspector in Unity. As you can see, I selected the icon.png, and now it's showing up in the inspector and telling me stuff about it. This is literally just whatever you have selected, it'll tell you about that thing, and it will also allow you to edit stuff if you want to or need to. But we're not gonna change anything on that. And then lastly, we have the node view, which is this tab right here beside the inspector. So if we click this, there's nothing because we don't have a node selected. But essentially, it tells you about, right here, like it says, signals and groups. Those are both things we will not be covering. But I just wanted to mention this window because it's pretty handy for when you use that stuff. All right, next. Are there any questions about what I just went over? Okay.
Nope, I think you're good.
Sweet. So, importing assets, it's really simple. You just drag and drop. So what we're going to do here is we're going to create a new folder. We're going to call it sprites. And this is where we're going to put our sprites. So I'm going to hop over here, grab the 2 sprites I made for this project, and just drop them in. And now, as you can see, they're in my project here. However, if I look at them, they're all blurry and gross looking. So we need to fix that. And the way you do that is you go to the import menu. This is another menu. It's beside the scene tab. You just pop over here, and here's all the stuff you can change when you're importing an asset. So for our sprites, since we don't want them to be blurry, we just have to turn filter off. And then we hit re-import. Whenever you change something in here, you have to hit re-import for it to work. But after we've done that, as you can see, now the sprite is sharp and not blurry at all. So we'll do the same thing for the worm. And now he's not blurry anymore either. And that's how you import any asset. Any kind of asset you want to import, you just import it. Drag and drop, easy peasy. You know what, I don't need this window anymore. And then I want to go back here. So yeah, that's all this was. Turn off filter, press re-import. Okay, so the node system. This is one of the harder things. Some people have trouble wrapping their heads around it, which it's kind of complicated, so it makes sense. But basically, the node system in Godot is based on inheritance. So you have the root node, which every node inherits, and then you have like a spatial node, which is for three-dimensional stuff. You have node 2D, which is for two-dimensional stuff, and then like you also have a sprite, which is a child of the node 2D, and stuff like that. You'll be familiar with this if you've done like any computer science courses. You'll know it from Java or whatever. It's the same thing, except in Godot, it's a little less explicit because of just how the system works. And then to create a scene, what we actually do here is we'll say create 2D scene. And what this does is this creates a node 2D for us. Now, this is the root node of our scene. The root of your scene determines what type of scene it is. So if you have a node 2D, it's a 2D scene. If you have a spatial node, it's a 3D scene, etc., etc. And you can have any node be a root node. Now, if we go here, we can see there's tons and tons of different types of nodes. Like, here's all the 2D nodes. Like, we have joints and all. There's a lot of stuff. We have collision objects, physics bodies. There are a lot of different types of nodes, basically for whatever you want. And we don't actually want that, so we'll get rid of it. So we're going to go here, and we're going to double-click on this node to change the name, and we're just going to change it to level. And that's just what I want to name my scene. So that's what I'm going to type as the name. So now I'm going to hit Control-S to save my scene. I'll create a folder, call it scenes, and then just save level.tscene right in there. And now our scene is saved. There's nothing in our scene, but it exists. Are there any questions on that? No? Okay. I'm just going to keep going until someone stops me. So if you have a question, do make sure to stop me. But the next thing we're going to do is we're going to create a player sprite. So there's two ways to create a node. You can either use this little plus button here, or you can right click and say add child node. So we're going to do that. And if we go under node 2D and go to sprite, which is right here, we can create a sprite. So we can either double click this or hit the create button. So if I just double click, it'll create it. Another thing you can do, just to demonstrate it, you can search nodes. So if we look up sprite, we get it here as well. Actually, didn't mean to create that. So this sprite here, we're going to rename it to player, because this guy's going to be our little player sprite. And then right now, like, you can't actually see anything. There's nothing here. So to assign an actual like texture to our sprite, we're just going to go into our sprites folder and grab our worm, and we're going to drag and drop it into the texture slot. And now, as you can see right over here, we got our little worm dude. He's right in there. So that's cool. Now, what happens if we run the scene? And the way you run a scene is with these buttons here. So this one plays a custom scene. So you click it, and then you select the scene to run. Alternatively, you can press this button to run the current scene. And then this button will run whatever your startup scene is. So if we press it, it'll complain because we have no startup scene. But that's okay. We don't really want one yet, so we're not going to worry about it. But if we press here to run the current scene, this boots up, and as you can see, there's not really anything going on. There's a little green worm guy in the corner. If I make the window bigger, he still just stays up in the corner. There's nothing really interesting going on with that. But this is our scene. So you might be wondering why the worm guy was in the corner. That's because if you look at these blue lines here, I'm not sure if you can see them in the video, but you'll be able to see them on your version of the editor. This is essentially our viewport. So it starts from here at 0, and it ends here at whatever this is. This will be equal to our screen size. And that will be our viewport that we see through. So if we grab our player and move him kind of over there, if we run this, as you can see now he's moved right in there. And if we make this bigger, he moves up there, and he's the same size. So that all works fine. All right, next thing. Scripting. The next thing we're going to do is we're going to make the player move around. So, yeah, that's... we're getting into kind of one of the harder bits, but I'm going to try to take it really slow and keep it really simple. So the first thing we're going to do is we're going to right-click on our player, and we're going to say Attach Script. So if we open up this window, there's quite a lot going on. This is what our script inherits. So that's essentially the type of node you can attach the script to. So if this inherited node, you could attach it to any kind of node, because every node is a node. You know, that makes sense. Node 2D, you could attach this to any 2D node. Alternatively, spatial, you could only attach to spatial nodes. But we want to attach it to, actually not a sprite. So we're going to cancel here. Because to move our player around, we want to use physics to do that. So we can't just have a sprite be our player. That won't work, because sprites aren't part of physics, right? So we're going to actually create a new node here. And if we go into Node 2D and into, where is it? I think it's under Collision Object and then Physics Body. We want a Kinematic Body 2D. So what this is this is a node that works in the physics system, but also its velocity and rotation and all that physics stuff is controlled by a script. So it's great for making players. That's actually why it has this little like guy running around as its icon. It's great for making characters. So we're going to call this player. Right, and it's going to be mad about that. So we're going to rename this to Sprite first. And then we'll call this player. And we're going to take the sprite, and we're going to drag it on top of the player. And now the sprite is a child of the player. So one thing we need to do is, as you can see by this little red thing, the player is located here in the corner. But the sprite is all the way over here. So if we move the player, the sprite will move with it. That's not really what we want. So we're going to go to the sprite. We're going to go to the inspector. And under this little thing that says transform, we can change its position. We're just going to hit the reset button, and that will change its position to 0, 0. And now, this player and sprite will move together in the same spot. So you might notice this little yellow thing here that says something about it not having like collision shapes. That's kind of weird. Basically, it's saying we need to add... Well, it's saying we need to add a collision shape. And a collision shape just determines what shape this object is in terms of the physics system. Right? So if we right-click here, we can just add a physics shape easily enough. We go here, we go to collision object, and... Oh, I was wrong. Right, here. We add a collision shape 2D. And we're going to name this collider, because that's essentially what it is. It's the collider. And now this one has a warning. The warning on our kinematic body went away, but now we have a warning on our collider saying we need to provide a shape. So if you go to the inspector, we have this little shape thing. And if we click it, we can create a bunch of different stuff. We can create a capsule shape, a circle shape, a concave polygon, a convex polygon, a line shape, a ray shape, a whole bunch of stuff. We just need a circle. Our player is a circle, right? More or less. So we're just going to use a circle. That makes sense. And then if we click on our circle, we can change the radius and some other stuff like the custom solver bias and some resource stuff. You're not really ever going to need these, so don't worry about them. But the radius, we're definitely going to need. So I know that my player sprite has a radius of 8 pixels. So I'm going to set the radius on my collision shape to 8. And now, as you can see, it just encompasses the player pretty nicely here. So I'm going to save that. And now, if we run the scene, you know, you might not be surprised, but still nothing is happening. we've created a player, but we haven't programmed them to move. So now this is where we get to actually start scripting for real. So now on our player, we're going to create a new script. And now if you notice, this inherits Kinematic Body 2D, which is what we want. We want to use the Kinematic Body to move the player around, right? And as you can see, it's going to save in our scenes folder as player.gd. We don't really want to save it in our scenes folder, so we're just going to hit this button and create a new folder. We'll call it scripts. And then we'll just hit open, and that'll open the folder, and that's where it's going to save our player script now. And we'll hit create. All right, scripting. This is where it gets kind of scary for everyone. Scripting is hard. So what's going on here? Well, first things first, we don't need any of this, so we're going to delete it, but I'll explain what it is first. So this first line extends Kinematic Body 2D. This is telling Godot that this inherits the Kinematic Body 2D component. So if we give this like a inheritance kind of look, like if I draw out this tree here, we have like whatever, and then we have the Kinematic Body, right? And then underneath that, inheriting that, is our player script, right? So that's how this inheritance tree works. These dots here are just whatever Kinematic Body inherits from, and then player is where we are. This next bit here is, these are all comments. Any line that starts with a hashtag is a comment. You might recognize this from Python. This entire language, it's called GD script, is very, very similar to Python. So a lot of Python things are the same in GD script. So if you've used Python before, this should be pretty easy to get used to. But yeah, anything after a hashtag is a comment. You can put literally whatever you want. You put slashes, stars, like it doesn't matter. It just gets ignored. So we don't actually need these comments, so we're going to get rid of them. And, okay, this is actually kind of a useful one. Called when the node enters the scene tree for the first time. Well, what is this? What's this thing? This is a function. So in GD script, you make a function by writing func, and then the name, and then brackets, a colon, and then whatever the function body is. So if you don't actually know what a function is like a repeated piece of code. And you can run that piece of code by calling the function. So for example, here in this ready function, if we call like name, that's how we call the name function. And then it'll run whatever code is in here. So in between these brackets would go arguments. Like you could say thing, other thing. And this is like, we could pass in, as you can see, it's angry now because we're not passing in arguments to our name call. So if we pass like 1 and 3, right? We could then print those out if we wanted. And that would work. And these don't even have to be numbers. This could be like a string, or things like that. So I should actually go over what, strings and numbers and the difference between all that is. So I'll do that just after functions here. So this function _ready, it's a special function. Basically, any function that starts with an underscore will be automatically called by Godot at a certain time. If you've used Unity before, it's like the start function or the update function. So _ready, what that does is it says right here, when the node enters the scene tree for the first time, this function gets called. But what does that actually mean? Well, this thing here, this is your scene tree, right? So when this node gets loaded into the game and is like loaded into the scene tree, this underscore ready function will get called. Once again, if you've used Unity, this is basically equivalent to the start function. Now, if we run this, what it's going to do is it's going to call the name function right away, and the name function is going to print whatever we pass in as arguments. So if I run this, and we look in our output here, we get 1 hello, which that's what we passed, 1 hello, and then we print out these two things, right? I'm hoping that makes sense. So that's what calling a function does. It just runs whatever code you have in here. So we're going to delete this name function because we don't actually need it anymore. And I'm going to write pass. So what pass does, it essentially tells GDScript, we're not running this function. We don't want to. And the reason we need that, if, for example, we get rid of this completely and save it, we get an error because it doesn't know what to do. There's nothing here, and it gets all confused. So we just write pass to say that there's nothing in this function. Now this next function here is actually commented out. Now what does this function do? Well, this is another underscore function, which means Godot is going to call it automatically at some point. And it also has a variable called delta that gets passed in. And right now it does nothing. But what if we write print delta, right? Because then we do two things. We can see what delta is, and we can kind of see when this function is called by seeing when the print statement happens. So if we run this, okay, so now a number, which is probably delta, is being printed like all the time. That's because process is called every frame. It even says right here. And then delta is the elapsed time since the previous frame. So effectively, once again, if you've used Unity, process is like update and delta is like time.delta time. If you haven't used Unity, process gets called every frame, which is every time like Godot draws things to the screen. And delta is the time in between frames, which allows you to scale things appropriately. I'll explain more about that later, but you won't really need it for now. So we don't actually need either of these functions for our player. So what we're going to do is we're going to delete them. And we're going to use a different function. It's called physics process. And as you can see, Godot autocompletes this for me. It actually has a very good autocomplete system in the built-in script editor. It's pretty well done, so that works. That works well. So what we're going to do here is right now we'll just write pass, but there is a lot of stuff we want to do. Essentially, physics process is a lot like the regular process, but it's called when physics updates. So the Unity equivalent would be fixed update. But yeah, this is just called whenever physics updates. And since we're moving the player with physics, we want to do our player updates in the physics update cycle, if that makes sense. So what we're going to do for now is we're going to actually hold on. I gotta remember where I'm at here. Let me double check my notes. Yeah, okay. So before we do this, one of the things we'll need to do is get the player input, right? So we have to set that up first. So we're going to go to project settings here. We're going to go to input map. And as you can see here, this is a whole bunch of stuff, which is just like buttons, essentially, and they have names. So we're going to add a few. We're going to add one called move up, move down, move left, and move right. And then we're just going to hit the plus button. We're going to make it a key. Up is going to be W. Whoops. Down is going to be S. left is going to be A, and right is going to be D. Now, these can be whatever you want. I'm just using WASD because that's what most games use for moving around. And we'll actually come back to why we need to do this in a minute. But now that that's set up, we're going to actually make the player move. So the first thing we're going to do is we're going to say var movement equals get movement. All right. What is this? There's this thing. It says var. We haven't seen that before. What does it do? Well, first things first, there's an error because get movement, which we're calling as a function, isn't declared in the current class. So first, before we do anything else, we're going to declare a function called get movement, and we're just going to write pass so that it's not angry at us. What's this whole var thing? Well, var is how you create a variable, and a variable is just a container for data. So data can take tons of different forms. Like we can say var number, and we can set it equal to like 1, or pi, or 999999999, or like negative 69, right? A number is just any real number. Another type of data is a Boolean, which we'll just call B, and that's either true or false. So it can either be true or it can be false. And what a Boolean is used for is in logic and stuff, you can say like, if something is true, do something, and if it's false, do something else, right? That's all Booleans are for. They're a way of abstracting logic. So true means, something is true. False means something is false. Next thing is a string. And that's just you have double quotes, and then you can write almost whatever you want. A couple caveats to that is you can't write more double quotes because then it gets confused, right? If we have extra double quotes in here, where does it end the string? Now it thinks all this is a string. That's not right. So what if you do want to write double quotes? You just put a backslash in there, and then it'll realize that, oh, you mean you want a quote in your string, and then it works. And a string is just text. So you can say string 2 equals 1, 2, 3, 4, 5, but this is not a number. This is still just numbers, or not numbers, this is like letters. This is more letters. It's just a string of characters. And if we print these, string, and we'll add a space, and we'll print string 2. If we run this in our physics processing, as you can see, it prints what we have, almost whatever you want, and then a quote, which is this little quote we put here, and then 1, 2, 3, 4, 5, which is what this is. You can also print any type of variable. So we could print, we could print string 2, then we could do another space, and we could print number, and then we could do another space, and then we could print B. And if we run that, as you can see, this is going to print out everything that we have, right? 1, 2, 3, 5, negative 69 is our number, and then false was our Boolean value. So that's basically what variables are. But now what's this? We're not like setting this to a value. We're setting it to like a function. Like what is that doesn't make sense. Well, what we're doing is we're saying movement is going to equal whatever this get movement function returns. Okay, what is returning? Well, the return value of a function is like a function in math. Like if you have like f of x equals x squared, right? F of 1 equals 1, right? F of 2 equals 4. Well, that value you get out of the function is the function's return value. In programming, the way you return a return value, at least in GD script, is you literally write return and then whatever value you want to return. For now, we'll say 5, right? We'll return 5. And then if we print this, this will just print 5 because that's what we've returned from the function. And that's literally all it is. It's the same as like setting it to 5, except we're returning this from a function. So that's cool. But now how are we going to actually get like player movement? That's that's kind of what the name implies we're doing. So how do we actually do that? Well, let's introduce a new variable type. We're going to call it var m. We're going to set it to a vector 2. Now, what is a vector 2? Well, a vector 2 is a two-dimensional vector. If you don't know what vectors are, it's numbers. They're used in physics and math and games. You learn it in, like, physics. I don't know. You can Google what they are. They're not too hard to wrap your head around. But this is just a two-dimensional vector, right? And what we've done is we've set the x-coordinate to 0 and the y-coordinate to 0. That's it. So now what do we do with this? This is kind of boring. Let's return m, right? So now what we're doing is we're creating a variable called m. We're setting it to a 0 vector. And then we're returning that vector. So if we run this, what happens? It just prints out 0, 0. Because that's what, that's what we set it to. It's a 0 vector. That makes sense. Now let's actually do something with this. This is where that input thing comes in handy. So we're going to say if input.is action pressed, and we'll say move up m.y minus equals 1. All right, what does this do? This is weird. Well, okay, remember earlier when I talked about Booleans being used for like if statements and stuff? That's what this is. This is an if statement. So for an if statement, you write if condition, a colon, and then whatever it is you want to do. So just like functions, if you don't have anything in your if statement, you have to write pass, otherwise it gets angry. This is just mad because, condition isn't declared. But if will take either true or false. If your condition is true, it'll run whatever's in here. If your condition is false, it won't run it. It'll just skip over it. Right? Now this true-false thing, that's not very helpful. I mean, if we just say if false, this will just never run, right? What's the point of that? Well, this here, this input function, this returns a Boolean. And basically what it's saying is we're taking the input class and we're saying if we're pressing the move up button. And if you remember in here, we declared move up and we declared it to be W, right? So if we're pressing the move up button, we're going to say m.y minus equals 1. And what this does is it'll take the y coordinate of m and it'll reduce it by 1. So it'll go from 0 to -1. And the reason we're doing that is because in Godot, the up direction is negative. So we're basically saying point this vector up, right? That's what we're doing there. So we're going to do that for the other directions now. We're going to say if input.is action pressed move down m.y plus equals 1. If input.is action pressed move left m.x minus equals 1. And if input.is action pressed move right m.x plus equals 1. All right, so now if you'll notice here, if we're doing plus and minus, what's going to happen is if we press up and down at the same time, this is going to set it to -1, and then immediately after it's going to set it back to 0, so we just won't move up or down. And that's what we want to happen, right? If we're pressing up and down at the same time, we just want the player, or we want the player not to move. So this makes sense. So then after we've done all that with m, we're just going to return it. So if we go up here, we're still printing movement. So if we run this, if we press the up button, we get -1. And if we let go, we get 0. If we press S, we get 1. A is -1 on the X. D is 1 on the X, right? And then if we press A and D at the same time, it's 0. If I let go of A, we get 1. So, you know, this works. This is pretty perfect. If we press both of them at once, we get 2 directions, right? It works. So that's good. We have that working. But now how do we actually make the player move? I mean, we've been doing all this stuff, and the player still doesn't move around. Like, what is this? Okay, we're going to do that. You say self.move and slide movement. So what's this now? Well, this, we're saying self, which references the current node, and then we're saying move and slide. Move and slide is a function, and we're passing movement as an argument to that function. So what move and slide does is it's part of the kinematic body 2D, which is why we have to extend it. It moves the kinematic body, and if it bumps into something, it slides along that surface. Now, we don't have anything to bump into yet, but when we get there, we'll be able to bump into things. So if we hit play and we run this, now if we're holding A and D and whatever, I'm moving, but I'm moving really, really slowly. Like, oh my goodness, that is really slow. Now, how do we fix that? I mean, I don't want to move that slow. Well, we can multiply this by a value. You know, we can multiply the vector by 5. We'll actually do it up here. Right? We'll multiply the vector by 5 and make it 5 times bigger. Now we'll move 5 times faster. That's still kind of slow. Right? So now I'll go back in here. I'll change the script. 10. Right? That's still kind of slow. But it seems kind of silly to go in and edit the code every time I want to change how fast the player goes, right? So what if we could like use a variable? Well, we can do that. What we do is we say export float var move speed equals, I'll say 32 because I already know that's a good value from when I tested this. But what does this mean? Well, this var part we know. We're declaring a variable, we're calling it move speed, and we're setting it to 32. But what's this export float part? Well, I will show by demonstration. If we go here, right here, we now have a variable called move speed in our inspector. And that's what export does. This is telling Godot to put this variable into the inspector and let us change it. Right? That's what export does. And then in the brackets here, this tells Godot what type to export. So you can put any type in here. We can put a float, vector2, we could put a string, we could put a Boolean, you know, whatever type we want, or even an integer if we want it to be integers instead of decimal numbers, right? Any type we want, we can put in there. We'll just say float for now because we want movement speed to be able to have decimal parts. And if we look at this now, we can change it from here, and it'll take effect in game. I don't actually want to change it because I know 32 is a good value, so I'm going to leave it. But trust me, you can change it. And if we run this, now when we move around, we actually move, and it's pretty decent. Now we have a player moving. I'm going to check my notes to see what we should do next. So we've done all this. And we're going to go to the next bit. Right. So project settings. We're going to do a little in-depth thing on that. Now, if you notice, when we run this, like the player's really small. That's kind of silly. Like, I wouldn't want to play a game like this. The player's way too tiny. So how do we change that? Well, in your project settings, if we go to general, there is a ton of stuff in here. We can change the application, audio, editor settings, debug settings, compression, blah, 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 blah. There's a lot of stuff. The main thing we're worried about is if we go to display, window. This is the main thing we're worried about. We can change the size of the window. So we're going to change the width to 1280 and the height to 720. This can be whatever you want. It doesn't really matter. But this is just the size of the window when you start the game. And we're going to go here to mode. And we're going to set this to 2D. And we're going to set this to expand. Or sorry, we just want this to be set to expand. This mode thing can be disabled. But what this will do is when we run this and we make the window bigger, it'll make the window nice and big, and actually the player is still pretty small. But we'll fix that. The window is nice and big now, and it keeps the aspect ratio or it expands the aspect ratio when you make it bigger. And we do actually want to set this to 2D, because now if we run this, when we make this bigger, the player actually scales up with the window. It's still really small, so we'll have to do some other stuff to make the player a decent size, but it at least scales up with the window now. So we'll hop in here, and if we want the player to be a good size, what we need to do for that is add a camera. Or sorry, not a camera. I'm being silly. We need to go back into project settings, and we set this shrink variable. We'll set it to like 4. Essentially what this does is it crunches the screen size down by however much you put in there. So if we set shrink to 4, right? Well, this is 1280 by 720. The actual screen resolution that your game is displayed on will be 4 times less than that. So if I show this here, the window's the same size, but our character is a lot bigger now. And another thing you might notice is the character is like chunking along here, all jittery, and it's just overall being kind of weird. This is because pixel snapping is being used, and the player is snapping to the nearest pixel when we move him, right? And that's not really what we want. You know, it looks bad. So maybe if we lower the movement speed, that'll help. And no, that didn't really help. Okay. Well, what else can we do? How do we fix this? The main thing you want to do is the reason the jitteriness happens is because the player is in between 2 pixels as they're moving, right? And that causes the jitter, and that's, you know, something we don't want. So how do we stop the player from being in between 2 pixels? Well, what we can do is we can get our position, right, with self.position. So self has a lot of handy variables on it, and position is one of them. This is just our position in the world. And then we can set it to a new vector 2 where we round the x position and the y position. And now, actually, this isn't, I've totally broken it. You know, I think that's because my movement speed, no, hold on. Why is this? Technical difficulties. Oh boy. Is this working now? No. I've broken something. Okay, what if we don't do this? Oh, I see. Yeah, it's because I was doing it in here. I actually want to do it right in here. So the problem was that I was doing it in the get movement function. I want to do it in this function after we actually move, and that should fix the problem. Sorry, we want to round our x position and round our y position. So this round function is just a built-in Godot function that rounds whatever number you put in to the nearest integer. That's all that does. There's also a bunch of built-in functions like min, which takes the smaller of 2 numbers, max, I think clamp is one. There's a ton of those, and you can see all of those in the Godot documentation, which I will link at the end of this lecture. So now if we run this, it's still broken. I don't know what I did. Okay. Okay, I've broken something pretty severely here, and I don't know what. Oh, I see. Was that it? Yeah, there we go. Now, as you can see, the player is moving just fine. and it's not broken anymore. And that was just because I messed up my move speed. And if we put this back in, I should now the jitter's gone as well. So that's perfect. That's now working as it should. And essentially what was happening before was, since my movement speed was so small and it was getting rounded, it was just getting rounded back to 0 every time. So this method is admittedly a bit hacky, and you do need to have like a high enough move speed for it to work. There are better ways to get around the jitteriness, like having a higher resolution, making your game not pixel art, or turning off pixel snapping, things like that. But they're more complex. This is like a simple 2-liner solution. So we're just going to use that for the purpose of this tutorial. So yeah, now if we move around, this works fine. This is perfect. But you might notice if we move in one direction, right, either on the X or Y axis, we move at, a normal speed. But if we move diagonally, we go faster. And that's not really something we want. But how do we fix that? And why does it happen? So the reason it happens, if you think about it, when we're pressing, let's say, up and left at the same time, our vector is -1, -1. And what happens is when we get it out to here, we just multiply it by move speed. So our move speed in each direction becomes like -64, -64. And that's not really what we want. Because if you think about it, like, the magnitude of this vector is higher than if it was just one direction, right? This has a higher magnitude than this. And we want the magnitude to be the same even if we're moving 2 directions. So we're just going to return m.normalize. Now what this is a function on the vector 2 that will normalize the vector and then return it from this function. And what normalization is it will make the length of the vector equal to 1. So if we have like -1, 1, after normalizing it, it'll be like -0.7 something and 0.7 something. And that's just to make the magnitude of the vector equal to 1. So now, what we're going to do is, now that this is normalized, if we run this, we go the same speed, diagonal, or, straight. Actually, it still kind of looks like we're going faster. That's weird. Oh, no, we totally aren't. I'm just weird. Okay. Yeah, so that's fine. So that's player movement done. And I am running low on time here. But let's do... Oh, yeah. One thing I wanted to go over is changing the physics settings. So if we go into Project and we go to Physics... oh, not that one. Where is it? Physics 2D. There is gravity, and we don't want gravity because this is a top-down game. So we're just going to set the gravity vector to 0. And now there won't be any gravity. This hasn't caused problems for us yet, but it might later, so we'll just do it now. Yeah, so the next thing, just kind of to wrap up, is a camera and making some obstacles. So the whole thing with the camera is like, our guy starts in the corner of the screen. That's weird. How do we move that? How do we make it not start in the corner? Well, one thing we could do is we can move our player, right? We could just move our player to the center here. But then if we change our screen size, it won't be in the center anymore. Like if I move the player to, let's say 128. No, that's nowhere near. Let's just grab this. Nope. If I grab the whole player and move them roughly to the center, so this is like 720 by 320. That's not really the center, but it's kind of close, right? They're actually gone because I think I moved them out of the screen. Right, point is, it gets weird if you don't just you know, it gets weird. So what we're going to do, we're just going to use a camera. So we just go here, and we say add child node. We'll search camera, add a camera 2D. We'll just rename it to camera. And we have to check this little box here that says current. This just says, you know, use this camera. This is the camera we want to use. And now we have this other blue box, and that is our camera. And the camera is what we're going to see through. And now, as you can see, the player starts in the center, and everything is nice and awesome and perfect. Now, one other thing we want to do is we'll add some obstacles just for fun. And this is just to demonstrate like static bodies. So if we go in here and we go to, well, I'll just search it. Static body 2D. This is kind of like the kinematic body, except we're saying it won't move. So we're going to name this bricks. And it has another warning that it doesn't have a collision shape. We're going to ignore that for now and add a sprite. This sprite is going to be the brick sprite. Just going to put it right in there. And now, as you can see, we have this little thing of bricks. And we're going to grab it. We're going to move it over here so it's not on top of the player. So right now, as it is, with this, remember there was the warning saying there's no collision shape? Yeah, we can't collide with it because there's no shape. So what we're going to do is we're just going to add a collision shape 2D. Call it a collider. And this is largely the same as how we did it on the player, right? Except this time we're going to pick a rectangle shape. And, oh dear. Okay, so it looks like I moved the sprite instead of the whole thing of bricks. So we'll move the whole thing of bricks to like -32, -32. Do that. And we're just going to set the collider. We're going to change the extents to 8 and 8. And now, that encapsulates the bricks pretty perfectly. And if we do this now, as you can see, we bump into it. We can't go through it anymore. And then we'll just duplicate this 3 more times. And now we have 4 bricks, and then we'll move them around to the positions we want, like +32 there, and then +32 there, and then +32 and +32. And now we have 4 walls that we can bump into. And yeah, while this is not much of a game per se, right? It's like, it's really simple. You just move a player around. That concludes our intro to Godot. So I hope, you know, everyone watching enjoyed. I hope it made sense. I hope I didn't ramble on too much. And I hope you all learned a lot. But if there's any last minute questions, please give them to me now. Otherwise, we'll just wrap it up. All right, I'm going to take that as a no. So thank you all for coming, and I'll see you later.
Liddy. Thank you for hosting, sir.
No problem. Did I make sense? Was that good?